Friends, today I am going to tell about thermoelectric effects of electric current. Before this, I would like to recall Joule's law of heating, which says that the rate of heat, which is power, evolved in a metallic conductor due to the passage of electric current is directly proportional to the square of resistance of the conductor. And if we can generate heat from electricity, the converse should be true, right? This is given by thermoelectric effects, which states that the process of producing electricity by keeping junctions of two dissimilar metals at different temperature. Basically, we keep two different metals at different temperature. I mean, the junctions are maintained at different temperature, so EMF is produced. The electricity is called as thermoelectricity, and the current thus produced is called as thermoelectric current. EMF is called as thermo-EMF. Thermocouple. This is an important topic. Thermocouple is a combination of two dissimilar metals joined with a galvanometer forming a loop. Basically, you can take two metals, example like copper and iron. There are two junctions which they meet, right? One is hot junction, which is maintained at high temperature, and the other one is cold junction, which is maintained at low temperature. At the hot junction, the metal having high free electron density, which is less work function, the electrons in that metal get excited, so they gain energy and move to the other metal. Thus, the flow of electrons, which creates electric current in the opposite direction of the flow of electrons. Here, free electron density of iron is greater than copper, thus current flows from copper to iron at the hot junction. It is opposite at the cold junction because it is a loop. Okay. Seeback effect. The production of EMF in a thermocouple when two junctions of that thermocouple are kept at different temperature is called Seeback effect. This is also called as thermoelectric effect. So, when the two junctions are maintained at two different temperature, at the hot junction, the electrons gain energy and move, which creates a current. This production of current, so there is a EMF generated between the two ends in which the electrons move. The production of EMF in this thermocouple is called as thermoelectric effect. The electricity thus formed depends upon the nature of the metals. So, if one metal has high free electron density and the other metal also has the same free electron density, there will be no EMF created. So, if one metal has high free electron density and other metal has low free electron density, then a EMF is created. To maximize this EMF, we will be taking antimony and bismuth. Thermoelectric series is arranged by Seeback. It is descending order of free electron density, which means antimony has high free electron density. Bismuth, which is at the bottom of the thermoelectric series, has low free electron density. The Seeback coefficient, corresponding Seeback coefficient is high if the free electron density is high and less if it is the opposite. Thermocouple between antimony and bismuth will give maximum EMF. The causes of thermoelectric effect or Seeback effect is that I just explained it. The electrons gain energy, thermal energy, and they move to the other metal. Thus, current is produced. Next, we will be seeing about the relation between thermo EMF and temperature of hot junction. The temperature of cold junction is denoted by Tc or theta C. Neutral temperature is denoted by theta n or Tn, and inversion temperature is denoted by theta I or Ti. The two ends, one end is maintained at high temperature by heating, keeping in a boiling oil bath. The other end is kept in ice. So the cold junction is 0 degrees Celsius. Basically, it is called as theta C, and the hot junction is like mentioned as just T. When the temperature of hot junction is increased, EMF is also increased. At the temperature, EMF becomes maximum. If we make hot junction below or above this temperature, EMF is reduced. The temperature at which the EMF is maximum is called as neutral temperature. And if we further increase the temperature, the EMF will be decreasing, and the temperature at which the EMF is 0 is called as the inversion temperature. Actually, there is a graph given below which is plotted between the thermo EMF and the temperature of the hot junction. It is a parabolic curve. So the equation of the curve is given by EMF is equal to alpha t plus half beta t square, or t or theta both the same. Alpha and beta are thermoelectric constants. In some questions they make you minus half beta square. They are just constants, so we neglect the sign and proceed with the constants given in the question. At neutral temperature, dE by dt is equal to 0. The rate of change of thermo EMF with respect to temperature is 0. With that, we derive the following equations. Theta n is equal to minus alpha by beta, and theta n is given by theta c plus theta I by 2. So we derive these formulas. Next, we move on to the Peltier effect. It is the converse of Seeback effect, which is here, if two junctions are kept at same temperature and current is passed through circuit of thermocouple, heat is generated at one end and absorbed at the other end. This cause of this effect is when the current is passed from metal of lower potential to higher potential, heat is absorbed. That is, thermal energy is absorbed by electrons. When current is passed from metal of higher to lower potential, heat is released. That is, the excess energy of electrons is converted into thermal energy. There is a coefficient called as Peltier coefficient, which is denoted by pi, which is given by delta H by delta Q, which is Peltier heat divided by charge flowing. It is its unit is volt. Causes when current is passed from metal having low potential to high potential, heat is absorbed. Thermal energy is absorbed by electrons. And the opposite occurs when current is passed from metal of higher to lower potential. Thomson effect. When unequally heated metals gets current, then heat is either evolved or absorbed. This is called as Thomson effect. There is two types of Thomson effect: positive Thomson effect and negative Thomson effect. When current flows from hot junction to cold junction, heat is released. When current is flowing from cold junction to hot junction, heat is absorbed. And the converse is true in negative Thomson effect. Metals or materials that show positive Thomson effect are copper, zinc and silver. The materials or metals which show negative Thomson effect is iron, bismuth and platinum. There is a coefficient called as Thomson coefficient, which is denoted by sigma, which is Thomson heat divided by the charge flown and the temperature difference. Last topic is thermophile. Thermophile is a device used to detect heat radiation. It works on Seeback effect. Thermocouple of antimony and bismuth are connected in series and two ends is connected with a galvanometer. Thermophile can detect temperature difference in order of 10 power minus 3 degrees Celsius. Hot junction receives heat radiation and then electrons from antimony move towards bismuth, thus creating a flow of electrons which is current. As there is a EMF generated, these electrons flow and constitute an electric current which can be detected by the galvanometer. Galvanometer shows deflection and the temperature difference can be measured. Thank you.